Welcome back, Year 10s. Hope you had a great break. Today, we're going to take a look at exercise 10.5, the unit circle. So the biggest thing for you guys to understand about the unit circle is at each intercept on the X and Y axes, it's always going to be 1. All right, so here would be 1, 0. Here would be coordinate 0, 1. This here would be negative 1 and 0. And then down here, this would be 0, negative 1. And so what that means is the radius is always going to be equal to 1. Okay, so radius equals 1 always. Now, for year 10, all we look at with the unit circle is with degrees. In methods, we convert everything into radians, which is essentially us using pi. So just for your reference, obviously 0 is still 0. But once we get into year 11 and 12, start getting used to seeing 180 degrees as pi. All right, so if pi is 180 degrees, this means 90 would be pi divided by 2, because if pi is 180 degrees, half of that is 90 degrees. Again, the proof you'll find later on next year. And then 270 degrees will be seen as 3 pi on 2, where we've got 3 times 180 divided by 2 equals to 270 degrees. If you're not sure, 3 times 180 is 540, and that's how we get the 270 degrees. Otherwise, the Cartesian plane still goes the same as always. Quadrant 1 is top right, quadrant 2 is top left, quadrant 3 is bottom left, and then quadrant 4 is bottom right. Just a short little acronym for you guys to remember. It's CAST. Okay, so C, A, S, and T. Again, you don't need to know this now, but I feel like we may as well. So what this means is all ratios. So all ratios positive. Again, this probably doesn't make any sense right now. All ratios positive in this quadrant. That's quadrant number 1. So it doesn't matter if you have sine, cosine, or tangent in here. It's always going to be positive. Down here in quadrant 4, only cosine. So only cosine positive. Okay, sine and tangent will be negative. And again, we'll go through the proof just a little bit later. The CAST acronym, so CAST, if you don't know how to spell CAST, is a good way to remember it. S here is sine. So only sine positive. And then down here, only tangent positive. What I might do is I might just change the color of the radians so it stands out a little bit. Let's see, let's use blue. All right, so this is pi on 2. This is pi. This is 3 pi on 2. Again, you don't need to know radians this year, but next year when you go into unit circles, you'll look at it and go, oh, I remember Ed talking about this last year. Okay, and then 360 would be 2 pi, and then 0 would be 0. All right, this part here is super important that we don't overlook. The radius is always equal to 1. And when we start putting triangles in the unit circle, what we're going to see is the radius is actually always going to be the hypotenuse, which is the longest side. Okay, so we'll take a look at that more in detail later. All right, but let's progress to example 1. So example 1 here says, state the quadrant of the unit circle in which each of the following angles is found. So if we have ourselves a unit circle, 140 degrees, so this is 90 degrees. Okay, this is 180 degrees. 145, sorry, is somewhere closer to 180. Okay. And remember, we always go from quadrant 1, so this point here, and then to our left. All right, so the starting point is always quadrant 1 on the x-axis, and this point here would be 145 degrees. So therefore, we know the top left quadrant is quadrant 2. Okay, the question just wants us to identify which quadrant the following degrees are in. Now for 280 degrees, 282 degrees. Let me try again. Let's try and draw the circle first. That's not bad. I'm happy with that. I'll take that. All right. Again, we start in the quadrant 1's x-axis, and then we go all the way around. Let's do the dot in the circle and a line in the circle. So here's 0. We get to 90. We get to 180. We get to 270. And then roughly here would be 282 degrees. Okay, you got 270 down here. Got 360 over here. All right, or 0, depending on which side of the rotation you're on. So this means we're in quadrant 4. Okay, so hopefully so far so good. We understand the quadrants. And again, is it super important that you know cast? Well, yeah, it's a shortcut, but you can always figure it out with our trig knowledge, which is what we're going to take a look at next. Okay, because when we take a look at trigonometric ratios within a unit circle, hopefully everything we've done so far in trig and triangles starts to piece together. All right, so if we exclusively, let's ignore cosine and tangent for now. If we take a look at sine, actually, let's see it holistically. We will see all three. What do we know about sine? Well, we know sine is sine theta equals opposite divided by hypotenuse. Okay, and we abbreviate that as so. With cosine, we know cos theta equals adjacent on hypotenuse. And then tangent equals opposite on adjacent, which is our SOHCAHTOA. And super important here, okay? Radius equals 1. So therefore, hypotenuse always equals 1. Oh, that's not 1. That's looking like 0. Okay, so what does that mean? Well, in our unit circle here, we can see x and y, all the intercepts are at 1 or -1, either on the x or y value. But even if I were to draw a random line like this, okay, this is still the radius because it's a circle, it's not an oblong shape. Okay, that's still going to be 1. Even if I drew a random line like this, that's going to be 1. Okay, so sometimes people forget the radius is always going to be equal to 1. So it doesn't matter how many lines I draw from the center to the outside, assuming it's nice and straight. Okay, it's always going to equal 1. Now, let's also highlight this so we don't forget. Let's use cyan. This is a big takeaway from the unit circle. I want you guys to make sure you understand this, so we never forget. Okay, the radius is so now tangent's a little weird because tangent it extends outside of the circle. We'll look at that one later. Okay, so we know here to here is going to be 1. All right. Let's ignore that for now. So what does that mean? Well, if we have an angle on the interior, so let's say this is 60 degrees. Let's say this is 60 degrees. Okay, remember the entire quadrant 1 is 90 degrees. If we have 60 degrees on the interior angle, well, for sine, if we have a nice right angle triangle here, so if we, let me see if I can get this a little bit slimmer. Okay, so let's pretend this angle here is 60 degrees. I'm just making that up. It looks about 60. Now let's make all of them 60 degrees. And so we know the hypotenuse is 1. Okay, and that's because the hypotenuse is a radius. And what we know is sine theta equals the opposite side divided by the hypotenuse. Well, the opposite side here is in orange. Oh, which one's orange? That one's orange. Okay, so the opposite side here is orange. Okay, and then the hypotenuse, what we notice is in sky blue. Damn it, I should have pre-wrote this. And we can do that for the other hypotenuse as well. Okay, so we can say hypotenuse here is a light blue line. The adjacent we've got in green. Okay, so it's easier to color coordinate just in case we're not following with what's going on. If you're not following, do send me an email so I can help you. All right, so let's look at sine and cosine for now. Well, what we know is now theta is 60 degrees. So therefore, we just zoom out a little bit. So therefore, if we were to substitute some values in, sine 60 degrees, okay, is going to equal the opposite. All right, we don't know what the opposite is. The opposite right now is a question mark. But if something's divided by 1, I'm sure you can figure it out pretty easily. Okay, so the opposite divided by the hypotenuse, which is 1. Okay, we know anything divided by, now that looks like a 0, doesn't it? So this is meant to say opposite. So anything divided by 1 is just going to be itself, like 6 divided by 1 is 6, 5 divided by 1 is 5. So opposite divided by 1 is just opposite. Okay, so therefore what we can say is, well, this interior angle here, sine 60, is equal to the opposite. Okay, so what does that mean? The opposite side length is sine 60 degrees. Okay, so if you go into your calculator, let me just write opposite one more time so I don't have to use orange. We can go into our calculator and we can say, well, what is sine 60? Sine 60 is root 3 on 2, which is also known as 0.866. Okay, let's say it's centimeters, meters, whatever it might be. So what that means is this question mark that we've got on the orange is going to be 0.866 in length, which is equivalent to sine 60 degrees. Okay. All right, so we can actually say the orange equals sine 60. So what you notice is we can actually draw this triangle 4 times. So back when we had the ambiguous case, we can kind of remix this triangle here. We can draw it here, and then we can also draw it here as well. Okay, so we've got like this, what's that? Star Wars spacecraft. It looks like one of those X fighters or whatever they're called. All right, and then all of these degrees will be 60 degrees. That's 60 degrees as well. And this here is also 60 degrees. And what you notice is they're all right angle triangles, meaning they're congruent, they're identical. So how do we distinguish them? Well, we can't call this one 60 degrees. We can't call this one 60 degrees. And likewise with the bottom two, because they're not distinguished. What we do is with the ambiguous cases, we learnt back in exercise 20.2, I think, with the sine rule. We go and figure out what 180, so we know this is 180. Okay, we go and take 60 degrees off 180, and we know this is going to be 120 degrees. Okay, so this entire angle from the dot to the second reflected triangle is going to be 120. Now, if you go sine 120 in your calculator, what do you get? 0.866 again, right? So we can say this side line here is also 0.866, and we know it's going to be a positive 0.866 because CAS and T. So C, cosine is positive, A, all the three trig ratios are positive here. S, only sine ratios are positive here. And again, if you want to prove it, just plug in, I guess, 1 and then the opposite side length to prove it. And then down here, okay, we're going to have a situation where we add 60 to 180. So this will be 240 degrees. So if you go in your calculator and go sine 240, what you should get is also 0.866, but you'll notice now it's a negative, okay, because of the coordinates we're in here. Okay, so we've got a negative hypotenuse and then a negative y value. Okay, over here, what we have again is a situation where we go and add, actually we subtract 60, so because it's attached to the x-axis here, we subtract 60 from 360, so this point here would be 300, and what you notice is we get sine 300 as 0.866 negative as well. All right, so four triangles that can be drawn in the same unit circle, identical, they're congruent. All right, but the side lengths are going to vary in positive and negative magnitudes. All right, so that's just a little fun fact for you guys. Not completely necessary right now, but I feel like it'll front load year 11 down the track and also year 12. All right, so this is very much year 12 based. And let's move on to cosine. So we know the radius is 1. Cosine, so adjacent here, okay? What we want to do is let's sub in the values first, one step at a time. So therefore, cosine 60 degrees equals the adjacent, which we don't know. So the adjacent's a mystery, okay? But we actually can figure this out pretty quickly. Hypotenuse, we know is going to be 1 because the radius is always a hypotenuse, and in a unit circle, the radius is always 1, okay? From there, well, this is the adjacent. And then if we were to divide the adjacent by 1, we just have adjacent, right? Just like 5 divided by 1 is 5. Adjacent divided by 1 is just adjacent. So therefore we can say cos 60 degrees is just equal to the adjacent. Damn it, I hate switching between these colors. All right. Okay. And what you notice is with sine, it's always the height of the triangle. With cosine, it's always going to be the width of the triangle. So sine is, in other words, our y, so height of triangle. In other words, that's going to be our y. So therefore y coordinate. Again, you'll learn about that later. Cosine is always the width, or yeah, let's call it width of triangle. And we know anything that runs along the width is our sort of x coordinate. So back to this. Well, if cosine 60 equals the adjacent, we can just plug that into our calculator to figure it out. Next year, they'll get you to try and remember the simple ones. So cosine 60 is just going to equal half. Adjacent. Okay, so what we can say here is this side length with the question mark is just going to be 0.5. Okay. So this side length here is just going to be 0.5. Nice and easy, which equals cosine 60. All right. Hopefully you're starting to figure out the fractions and decimals that associate with trigonometric ratios and their respective angles once you plug it in. All right. If it doesn't, please do email. And now we take a look at the tangent. So the tangent's a weirdo. We know the tangent is outside of the circle and it touches the circle at one point, but the tangent is cut off by the x-axis and the radius extended out, sort of like a chord. Okay, but it kind of stops at the center. And so what you just got to think is tangent. Okay, so always between x-axis and radius extended. And so hopefully you can kind of problem solve already how to find the tangent, all right, without knowing the tangent ratio, just using triangles. The tangent is like the big brother to the sine side length. Okay, if we can figure out cosine and if we can figure out the sine side length, okay, or meaning the width and height, we can figure out the tangent's height. Okay, so this big orange line is the tangent's height. All right, so we know from this triangle, okay, this length here is sine 60. Some of you might prefer 0.866. I'm just going to write it as sine 60 so you're used to it. Down here, we know this is cos 60 because we did it in the previous question. All right, so we got sine 60, cosine 60, sine 60 as our height, cosine 60 as our width. All right, what we can do is we can establish this is our opposite. This is our adjacent to our right angle triangle here. And together, if we divide these two, opposite divided by adjacent, we can actually figure out this big tangent line that's extended outside of the circle. So therefore, what we can say is tan 60 degrees equals the opposite, which is sine 60. Maybe I should write it in the same color, shouldn't I? Let's keep it orange. The consistency matters because, well, some people might not watch this video and just look at the notes. So this is opposite. So opposite is sine 60, or AKA 0.866. divided by the adjacent, which we had in green. Okay, so the adjacent we have here in green, which was cosine 60. Yeah, that's our adjacent. All right, and then all you have to do is in your calculator, you plug these in. So let's see what we get. Oops, that's the wrong button. Sine 60, or you could input 0.866 divided by cosine 60. This will get us root 3. In other words, so at tan 60 degrees, we get a length of 1.73. So that's why when you look at these answers, right, like you can sort of pass the eye test. So here we've got the tangent. This tangent in orange looks bigger than 1. All right, it's way bigger than 1. All right, the hypotenuse here is 1, and that's radius. Okay, because tangents outside of the circles, it's bigger than 1, and 1.73, that looks pretty much spot on. With this situation down here, 0.5 for cosine at 60 degrees. Yeah, that looks about half. That's pretty spot on. Obviously, I didn't make it exactly proportional. I didn't measure it out, but if I did, this should be exactly half. And then for sine at 60 degrees, well, yeah, it looks smaller than 1, but it's definitely bigger than half. So 0.866 for this height length here is pretty spot on. Okay, so I'm pretty confident in our answers here. And what we have done is just applied trigonometry into the unit circle. Now, the biggest thing for you guys to understand the unit circle is the hypotenuse is always 1. And to find the tangent, you need to know what the sine and cosine ratios are first before you get to the tangent, where it's opposite divided by adjacent. And I just realized the A wasn't in green. So let me just patch that up. All right, so I'm hoping this makes sense. And let's move on to the last one. All right, so here it says, find the approximate value of each of the following using the unit circle. Should be nice and easy. So 200 degrees, cosine 200 degrees, sine 200 is the first one. So let's write that one in. This one here can be cosine 200 degrees, tangent 200 degrees. And obviously I didn't go ahead and pre-plan the lines, but what you can imagine is, let's say they're all the same. I'm going to try and draw them roughly the same. Damn it, that's not the same. It's got to look at least remotely close. Yeah, all right, give me a second, guys. So it's meant to be 3 identical. All right, so we know this is 180 degrees, okay, because we always travel this way. Okay, and then that means this here would be 20 degrees, and this over here would be 200 degrees. Same with this, and same with this. Okay, hopefully the Zoom isn't too irritating. So it says find the approximate value. All you got to do is use your calculator, but if you want to use the true ratios, okay, this here would be sine 200. Actually, let's use 20. So I'll show you the cast method. Guys, obviously you can type in sine 200 and it'll tell you the answer, but just to show you the cast method. Okay, so cosine positive, all trig ratios are positive. Sine's positive in the quadrant 2, and tan is positive in quadrant, quadrant 3. All right, so right away we can see sine is going to be negative. All right, so it's going to be a negative opposite divided by hypotenuse. So therefore sine 20 is going to equal, well, the opposite is a mystery. Okay, so the opposite is just going to be a mystery. And then the hypotenuse is going to be 1 because the hypotenuse is a radius. Okay, so therefore, sine 20 equals opposite. We can input sine 20 into our calculator. Sine 20 equals a positive 0.342, but because it's negative, we put the negative and carry it down, making sure we don't forget. All right, so this is a negative 0.342. Now, what you do is in your calculator, you can also go sine 200, and boom, it gets you negative 0.342. But in method, sometimes you won't have a calculator, so it's important to know the cast method as well. All right. Over here, cosine, same thing, 20 degrees. Okay, we go this way always, so we always go here. So this is 180 degrees. What we can say is cosine is going to be the adjacent divided by hypotenuse, and we write the cast method. We know tangent is the only positive one in the third quadrant, so we put a negative here. Okay, cosine is positive in the fourth quadrant. Okay, so that's why we put the negative. What we do here is cosine 20 equals, carry the negative down. Well, the adjacent is unknown, so we just write adjacent divided by the hypotenuse, which is 1. Okay, so it's really important that we know hypotenuse is 1. Okay, as we highlighted earlier. Okay, hypotenuse, radius in the unit circle, hypotenuse and radius, same thing, drill that into your brain. Okay, so that just means cosine of 20 degrees is equal to negative adjacent. Okay, so I forgot this. Damn it. Knew there was a side missing. All right, let's try and keep the line straight. Yeah, you can see the triangle there. All right, so cosine 20 is going to equal 0.939693. So therefore, because it's in quadrant 3, where it's a negative situation, it'll be a negative 0.939693. All right, obviously they'll tell you to round to 2 decimal places or whatnot. And the reason why we use radians in year 11 and 12 is because a lot of these answers are irrational. With pi, we can get like essentially third situations a lot easier. All right, the last one here, tangent. Okay, so tangent, the big brother of sine. If we have two hundreds in the way. If we have a line like this, and then this extends out. Okay, the tangent triangle's right angle would be here. Oh boy, let's try again. Okay. I know. All right. Try and make it as straight as possible. Now, obviously, the tangent line doesn't extend beyond the x. All right, so this is going to be a nice and small tangent. Okay, so we can expect this to be under 1 already. See if we can make it a different color. All right. Is that touching? Yes. Okay, good enough. Oh my goodness. All right, if we zoom out, that might. Nope. I cannot wait to be back in the classroom, that's for sure. All right, so we get it. So the tangent line is outside of the circle in orange, and we know tangent is going to be negative in the 4th quadrant. All right, this is going to be 20 degrees. Damn it, that says 200. That's 20 degrees, okay, because this here is 200 degrees. All right, because we always travel this way, that's 180. So therefore, tan 20 equals the opposite side. The opposite side, as we know, for height is always sine. So we know the opposite side is sine 20. Okay, and sine 20 is this negative 0.342. So if you want to plug in the decimals, you can instead of the trig ratios. And then divided by the adjacent, which is the horizontal, which is cosine 20. Okay, if you want to plug in negative 0.9396, you can do so. And so we know tan is going to be positive in this quadrant because we have 2 negatives. All right, so we've got a negative answer for sine 20 and then a negative answer for cosine 20. All right, so basically they're going to be both negatives, which means tan with 20 degrees is going to equal these two divided together. What is it? Let's see. Negative cosine 20 divided, damn it, negative sine 20 divided by cosine 20. Okay, so we got a positive 0.36397. All right, as our height here. And that passes the eye test. You know, it's not something that's an abnormally large line. Okay, so you can always check with the eye test to see what you get. And then double checking, we can also go tangent 200 to see what we get. And it's positive 0.36397, which is an irrational number as our answer. All right, so there you have it. Shortcut to this is obviously you can just punch it into the calculator. But again, we want to see fully by hand how everything works. All right, because ultimately you have to do this in year 11 and 12 if you're doing methods. Thanks for listening. If you have any questions, do email them through. Thanks, everybody.